floor to Lucas that will describe our other innovation engineering challenge. So Lucas, go ahead.
Thank you, Cristiano. Hi, everyone. I'm Lucas. I'm one of the fellows of the School of AI this session. And I want to talk a little to you guys about our challenge. Our challenge was also sponsored by Innovation Engineering, and it's called the Semantic Taxonomy Builder. So what is the Semantic Taxonomy Builder and what we want to do with that? To talk about that, we also want to talk a little about WISB. And the WISB is a platform that they provide. And it's a platform that basically provides insights on any given technology. So if the user wants to know anything about nanotechnology, let's say, the platform is going to retrieve a lot of information about that. So what's the problem then? The problem here is that this information comes in from many different sources and it's organized in many different data sets. If you guys see in green, each data source, it's going to come with a native label. And those labels don't really map very well across themselves. On top of that, many of the documents they have doesn't have those labels at all. So it's simply impossible to explore different taxonomies from anything that you query, basically. A little more on the mix, we call it. This is not the final view of it. They just keep adding more data sources, more data sets. So it's a big problem now. It's going to be it's going to be much bigger later on. So what's the solution that we're proposing here? We are proposing that we shouldn't rely on the taxonomy provided by the source. We should instead use that information to build our own taxonomy. So what does that mean? It means that we'll be able to classify any document with any of the labels. At least that's the plan. So just a little on the data itself, you guys can see there, patents usually will come with CPC and categories, labels, and other types of documents are going to come with fields of study, ASJC, and those are the ones that don't really match very well across themselves. What's the value that will bring? Why we want to do that? Why we want to have a common taxonomy? Well, first, a system like that can label millions of documents in an instant. That's something that no human could do. And this will be used to create the cross data set taxonomy. Also, this is a system that can be kept online. So any other document that comes into the platform will be able to be labeled instantly. And that aims to greatly reduce the manual work, even for the end user who is trying to find a technology in a specific sector, let's say, that can help him. And also it can create new ways of analyzing technologies into taxonomy groups. You know, it's something that we currently cannot do. So a little about the steps that we are taking to achieve that. We separate in 4 different steps, which is going to be first finding the labels, find potential labels inside of the data sets, then calculating the embeddings for the documents, which is basically a numerical representation of the text on the document. Then we can use that to calculate the labels on the native data set, the data set that the label belongs to, and then hopefully exploit the same method to cross-correlate those data sets. So basically label data sets with labels that don't belong there. They are not native to that data set. So how we do that? Let's talk about the steps then. The first step is finding the labels. Finding labels is very easy. There is plenty to choose from on the platform. So for instance, there are ASJC for papers, CPC for patents, sector for grants, you name it. There's plenty of them. We are taking ASJC as our example here, but it could be any of them. ASJCs are pretty good because they are global standard for labeling papers, but even then, a lot of the paper, millions of them, doesn't have the label at all. So good, we got the labels, we went to the embeddings. Embeddings are numerical representations of the title, abstract, and things like that from the documents. And we actually leveraging a state-of-the-art algorithm and embedding system from Alien AI Institute of Artificial Intelligence called Spectre, and basically tailored that to our needs. So after that, we have the labels, we have the embeddings. What we can do with that? We actually can train the model with those things. On the middle of the picture, you can see there is a ASJC model. That's the model that we use that to train. And it actually can label unlabeled papers, in this case, with ASJC codes. So you take a paper, you create embeddings, pass through our model, and it's going to label that paper for you with ASJC. The table on the right is the actual scores from some of the models that we tried. If you see the highlighted one, we got around 70% of accuracy in a top 10 label suggestions, which means that for any paper that we feed this model, the correct label, it's going to be on the top 10. A little examples on the bottom table. If you see, there's the original labels and the suggested labels. Usually the correct label is there. But even when it's not, if you check the other labels, it all makes sense in a semantic way. So it belongs to the same taxonomy. So we think that's a pretty good result. What else we can do with this model? Now that we have a model trained to calculate ASJCs, we don't have to stop there. We can actually go and label the other data sets with the same technique. So in this case, we're taking the patents and passing through our model trained on papers, and we're going to get ASJCs for the patents, which is something that's not native to this data set. So this will allow us to label documents in non-native taxonomies from that particular data set. So anyway, this is the team. It's me, Ravindra. I'm from Brazil. Ravindra is from India. So we are speaking from across the globe here. And I want to give a special thanks for our mentor, Alberto, which helped us a lot. So Alberto, thank you very much. Without you, this couldn't be done. So that's it, guys. Thank you very much.
Thanks, Lucas. Yeah, Cristiano again. I also coach this challenge. So we are showing you what Lucas just mentioned, and we are showing you the final result. But actually, this team started off with a really completely different challenge. It was on trends analysis related, let's say, to time series. We had weekly calls with the stakeholders, like the usual Paris School challenge, but this time it was exceptionally useful. After 6 weeks, we realized that due to the data we had and property of the challenge we had identified at the beginning, we couldn't make progress. We were stuck. So we agreed with innovation engineering to pivot, and we defined a new challenge on taxonomy mapping, the one that Lucas just talked about. It was useful to have our mentor Alberto by our side, and it was very helpful in mitigating the issues with pivoting. I think this is important. I want to highlight it. You see, in data science, it often happens to change plans, and you should be comfortable with it. At PySchool, we are proud to be able to select the best fellows and put in our competencies to help them. So thank you, Lucas.